Hello, geometry family. I wanted to make a video for today so that you guys had some sound as you were trying to learn how to do some constructions. So me and my buddy Pete back here, nope, he's on this side, my little buddy Pete back here are going to walk you through a couple quick constructions. So you will want to watch this and probably have your compass handy. If you don't have your compass handy right now, just try to remember what you can, all right? So we are going through the notes that are day 4 in your packet. And day 4 is on page 10. So grab your compass and your ruler and let's get started. Now, hopefully everything will work out even though I'm doing this from home. We're about to see. So this thing says create a triangle whose sides match the lengths of the given segments. What type of triangle will you have? Well, if I look at those 3 segments, they're 3 different sizes. And a triangle with 3 different sizes would be a scalene triangle. Okay? So if I have to make a triangle like that, the first thing I'm going to do is I am going to draw my base. Now, I don't know how long it's going to be, so I'm just going to make it that long. Then I am going to take that base and shrink it a little bit. I am going to make my base, whoops, ignore that. I am going to make my base as long as A, and it doesn't matter which side you start with. I just prefer to start with the long side. So I am going to measure how long A is with my compass. I am going to then bring my compass over to here, and I am going to draw an arc. And once I draw that arc, one other thing I like to do is once I've found out that I don't need the rest of this, I literally just scribble it out because I don't need it anymore. So A is going to be my base. Now I want B to be the left-hand side. So I'm going to come over here with my compass. I'm going to measure B. And then I am going to bring my compass to the left-hand side, put the pokey part on the left-hand side, and I am going to draw an arc like that. Now I want C to be the right-hand side. So I am again going to use my compass to measure. And now I'm going to measure C. Let's see. It's a little bit too big. There we go. I'm going to measure C with my compass. Now I'm going to bring my compass over here and put the pokey part on the right-hand side of the line. Okay, now notice I'm using the right-hand side of A, not where this other arc intersected. I'm going where A intersected, okay? So come all the way over to this right-hand side, draw another arc. I am then going to put a dot where those 2 intersected. And then I am going to connect the left-hand side to there and the right-hand side to there. And now I have marked off 3 segments. A is down here, B is on the left, and C is on the right. That's it. So when you create a triangle, you want to draw a random base, then mark it off with how long you want it to be. Draw a left-hand side on the left with an arc, a right-hand side on the right with an arc, and then connect to the intersection. Create an isosceles triangle where A is the base. Oh, so I'm just going to draw A, and then I'm going to use B twice, because remember the base of an isosceles is the bottom, and the legs are going to go left and right. So here, what just happened here? I got to draw my lines. So I'm going to make A the base. So here's something that's probably too long. Grab my compass. Come here, little compass. And then I am going to measure, and there's Landon, who I'm homesick with. I am going to measure how long A is with my compass. Come over here and arc it off. Scribble out what I don't need. And now I need to use B twice. So I'm going to come back over here, open my compass up as wide as B. All right, so I am as wide as B now. I'm going to bring the pokey part to the left-hand side. And you know what? To make sure we don't accidentally look at the bottom, I don't need that arc to touch the line at all. I really need it to be up here somewhere. So I'm going to draw that arc up here. I'm going to come over here to the other side of my base, draw an arc until it hits the first one, and then I'm going to connect the dots. This goes to the intersection. That goes to the intersection. So now I have 1 length of A and 2 lengths of B. And then last but not least, create an isosceles triangle where B is the base. I mean, okay. So I'm going to draw a random base. I'm going to snatch my compass and make that base as long as B. So come down here. Oh, look at that. It's already B long. That's helpful. I'm going to make my base B long. Scribble out the rest. Don't need you. And then I want my 2 legs to be A long. So I will bring my compass over to here. Open this up so that it's A long. And if I think about where these intersect, they're going to intersect up top here. So I don't need to draw a huge arc, just an arc that's long enough to crisscross where I think it should, which would be up there. And now I am going to connect the dots, left and right, to the top. And I have a B long base and sides of length A. Now, you don't need to label the sides A and B like I did, but I wanted to make sure you guys understood which things were how long. Almost done. Look at that. This is going to be quick notes here. Constructing a regular hexagon. So if you want to see this over again, there's obviously a QR code here. And if you notice, there are QR codes over here as well. So if you need to see this again, you can use those QR codes or go to Math Open Ref. And there's a link for that on our teams. And you can use Math Open Ref, which may be where at least one of these QR codes takes you anyway. All right, constructing a regular hexagon. Before I even do this construction, I want to fill in the blanks down here. Okay, some words that you really need to know are words such as regular. A regular polygon has all equal sides, all equal angles. That's what regular means. A regular polygon is a polygon with all equal sides and all equal angles. And inscribed, we are going to make an inscribed hexagon. Inscribed means that there is a shape whose corners or vertices are on a circle. And let me make this smaller because holy cow, that's pretty big text. There we go. Da-da-da. So regular means all equal sides, all equal angles. And inscribed means you're going to draw a shape whose corners or vertices are all on the circle. Now, technically, inscribed, you can have a circle inscribed in a shape or a shape inscribed in a circle. And we'll talk about that a little bit more later. But for our purposes today, inscribed means we're going to draw a hexagon where all the vertices are on the edge of a circle. So let's do it. Let's construct a regular hexagon. And I got to be honest, this is one of my favorite ones to make. I don't know why. I just find it fun. So the first thing you're going to do is put a random point right here. And we're going to draw a circle. So I am going to grab my compass. I am going to put the pokey part on that point. And I am going to open my compass enough that it fits in here. Okay? Just a random opening. As long as it fits on the page, you're good. And then I am going to draw a circle. Da-da-da. Then, without changing the width of the compass, you're again going to grab any random spot on the circle, doesn't matter where, and you are going to draw 6 arcs that intersect your circle. 1. Then I'm going to move to that intersection. 2. Then I'm going to move to that intersection. 3. Then I'm going to move to that intersection. Do you sense a pattern? 4. Move. 5. Move. 6. And I'm going to stop at 6 because a hexagon has 6 sides. Now, your arcs do not need to be as big as mine, but obviously I am using this ridiculous compass. I have 6 dots that I am going to connect to create my hexagon. So now I'm going to take my ruler And I am going to go from one spot on the circle to the next spot on the circle. One spot to the next. One spot to the next. To the next. To the next. To the next. Da da da. Now I have a regular inscribed hexagon. See how that hexagon has all 6 corners touching the circle? Yep, I see it too. You've got an inscribed hexagon. Awesome. Now, if we scroll down, it says, how could you use that hexagon to make an equilateral triangle instead? Well, a hexagon has 6 sides. A triangle only has 3. Instead of connecting all 6 dots, I could connect every other dot to make a triangle instead. So I'm going to go back up here and do it. And so are you. So if I started, let's say here, instead of going to the very next dot, I'm going to skip it and go over here. Instead of going to the very next dot, I'm going to skip it and go there. Instead of here, go there. And now I have a triangle. And now we're done. So that is the end of our notes on constructing a regular hexagon, constructing an equilateral triangle, and just making some triangles with random given lengths. So hopefully that all made sense to you. Your notes are done. Now you should go and do the homework in your homework packet. I hope everybody is having a great day. Hey, Pete, say bye, Pete. Where is he? There he is. I can't get my camera to look at him, but that's Pete. He's having a good time. I hope you guys are having a great day. Toodaloo.